All right, today we are covering 6-1, which is Introduction to Polynomials. So we have a couple learning targets: identify and evaluate, add and subtract polynomials, and then also classify them. All right, a few definitions. Monomial. So monomial is a number or a product of numbers and variables with whole number exponents. Basically, it's one single term. So mono means one. So polynomial is a collection, a monomial or sum or difference of monomials. So you'll have either one monomial or you'll have monomials with plus and minus signs in between them. Monomial is the simplest polynomial because it only has one term. So polynomials have no variables in the denominator or exponents, no roots or absolute values of variables, and all variables have whole number exponents. So let's look at examples of things that all are polynomials. So here we have a variable to an exponent, but the exponent itself is not a variable. Here we have two monomials added together. Here we have a variable again that has an exponent, variable with an exponent, and then variables or difference of two monomials with exponents. Those are all proper polynomials. The following are not polynomials. So you can see the difference. Here the exponent is a variable, so that's not a polynomial. Here we have absolute value signs. Here we have a variable in the denominator. This is a rational expression. We'll get to those later. This is square root. And basically a square root is the same as, this is actually the same as x, or 1/2 x to the 1/2 power. So the exponent is really a fractional exponent, which is why that's not a polynomial. And then here we have fractional exponents again. The degree of a monomial is the sum of the exponents of the variables. So if you only have one variable, then it's just going to be the degree of that variable. But sometimes monomials have multiple variables in them. All right, so here's examples. Identify the degree of each of the monomials. So this monomial, z to the 6th, it only has one variable, so obviously the degree is just going to be the exponent, which is 6. Whoops, let's go. Oops. Here, this is a little bit trickier. 5.6, you don't really see a variable or an exponent, but it has an implied one, which is just going to be some variable. In this case, we just call it x to the 0th power. Remember, anything to the 0 power is 1. So if it doesn't have a variable, the degree is always going to be 0, because that's basically the implied exponent of that expression. All right. Now we have an expression with multiple variables in it. So if it doesn't have a variable, an exponent such as the x, the implied exponent is 1. So we're just going to add those two exponents together, and we're going to get a degree of 4. Oops. Can't move that away. Okay, the next one, again, the implied exponent here is 1, so we're going to add 2 plus 1 plus 3 and get a degree of 6. All right, so if you're viewing this video, you should either do this in your notes so I can stamp it, or do it when we're doing the lesson. I want you to identify the degree of those monomials, as well as these. All right, so the degree of a polynomial is a little different. It's given by the term with the greatest degree. So if you have 3 monomials added together, you're going to look at the one that has the highest degree. And we've just learned how to define the degree of each monomial. In standard form, the degree of the first term indicates the degree of the polynomial. So in standard form means that your highest exponent is to the left and it decreases as you work your way to the right. The leading coefficient, the leading coefficient is the coefficient of the first term as well. So this is if it's in standard form. Here's the picture of standard form. So here's our leading coefficient, and the degree of the polynomial, because this is, since in standard form, our highest exponent is here, and you can see this one, our exponent is basically going to be x to the 0, and that means the degree of this one is 0. So here are the degrees of each term. This is standard form, and this shows you what the leading coefficient degree of the actual polynomial, which is all those terms added together. So a polynomial with 2 terms is called binomial. A polynomial with 3 terms is called a trinomial. And then we can also classify a polynomial by its degree. So here's a table of the names of various polynomials based on their degree. And so when you classify and name a polynomial, you're going to either use binomial, trinomial. If it's not, doesn't have 2 terms, or monomial, I suppose. So if it doesn't have 1, 2, or 3 terms, then you're just going to classify it as a polynomial beyond 3 terms. And then, based on the degree, if the degree is 0, it's going to be constant. If the degree is 1, it's linear. So you can see why, because basically it's a linear equation if it were in equation form. Quadratic is of degree 2, because this looks like quadratic equations. If we've got 3, it's going to be cubic. So this would be cubic. 4 is actually quartic. So it's kind of hard to just remember between quadratic and quartic. But if you remember quadratic equations are x squared equations, then that should help you. And then lastly, as far as we're going to go, is the 5th power, which is quintic. So we're going to practice naming polynomials based on the number of terms and the degrees. All right, rewrite each polynomial in standard form. Identify the leading coefficient, degree, and number of terms. Name the polynomial. All right, so first we want to rewrite it in standard form. I don't know why I can't throw this away. I'll just move it out of the way. So obviously our highest exponent is this. So it's going to be negative 5x squared, don't forget the negative sign, plus 4x plus 3. Now we want to identify the leading coefficient. Leading coefficient, now that it's in standard form, is going to be this, which is negative 5. Oops. And degree is going to be 2, because that's the exponent of our leading term in standard form. Number of terms is 3. And the name of the polynomial. So, oops, let's see if I can grab this and get rid of it for now. So leading coefficient is negative 5. Degree 2. Number of terms. And then we've got 3 terms, so it's a trinomial, and the highest exponent is 2. It's of degree 2, so it's going to be a quadratic trinomial. All right, next one. So when we rewrite this in standard form, this is going to be, whoops, this is going to be our first term. So here it is rewritten in standard form. And then leading coefficient, obviously, is going to be our 8. Degree is going to be 4. Number of terms, 3. So again, we have a trinomial, but it's to the 4th power, so it's going to be a quartic trinomial. All right, so next page has some for you to identify. And again, this is something you can do in class. If you want to do it in your notes now and show it to me, then you can go ahead and do it now. So you're supposed to do the same thing, rewrite in standard form, identify leading coefficient, the leading coefficient, degree, number of terms, and name the polynomial. All right, add or subtract. So this is, we're just going to add and or subtract like terms. And don't forget, if it's a subtraction to distribute the negative sign. So we're going to kind of group together our variables of this with the same variables and or the monomials with the same variables and exponents. So 2 to the, that's ugly color. 2 cubed is going to be our first term, and we want to have the final answer in standard form. So 2x cubed, then squared is going to be, well actually, so we have an x cubed and an x cubed. So we're going to group those together. And then we have an x squared term here, and that's the only one we have. So plus 5x squared. We have 2x terms. So that's going to be plus 7x minus x. And then lastly, we have 2 constants that we will group together. So plus 9 plus 4. So if we add that, we've got 2x cubed plus 1x cubed is 3x cubed. We've got 5x squared. That was the only one we had. Plus 7x minus 7x is going to be plus 6x, and 9 plus 4 is 13. So our final answer should look like that, and hopefully I did that right. And that's what they have as well for their answer. All right, the next one is a subtraction, so remember to distribute this across all your terms. So we're going to end up with x squared is our, so negative, I'm going to rewrite this as negative 2x squared plus 3, and then I'm going to distribute this, so it's going to be a minus x squared. A minus of a minus makes it a plus x, and then minus 6. And then I can start grouping my, or adding together my like terms. I have a 2x squared minus x squared gives me 1x squared, or a negative x squared. Let's see, we have positive x, and then we've got positive 3, and negative 6 is going to be a negative 3. And hopefully that's what they have for their answer. Whoops, nope, I did it wrong. This actually is a negative 2 and negative x, not a positive. So good thing I have the answers here. This actually is a negative 3. And I know if we were in class, you would all be telling me that. So our final answer then is negative 3x squared plus x minus 3. Okay, so there's a couple that you would want to do. Actually, there's just one. So do that one. Either do it in class when we do it in, as a class, or you can do it in your notes. And that wraps up our introduction to polynomials. So this is your homework. So write it down if you want to work on it in class. There will be a new web activity on Monday. Write down any questions you have, and I will see you next time.